Okay, this is section 3.3 part 2. This is the second part of our notes for section 3.3, and it's on graphing lines and what it means to be parallel and perpendicular in regards to slope. The first thing we got up here is a triangle with a line through it. Now this is important because this triangle shows you all four types of slope. You can have a positive slope, which will go up to the right, or a negative slope, which will fall to the right, and then our other two are our vertical and horizontal lines, which we talked about in our last video. We said a horizontal line has a slope that's 0, because it's got a 0 in the numerator and a number on the bottom. And our vertical lines have a slope that's undefined, because you get a number in the denominator, and you can't divide by 0. You get a 0 in the denominator, a number in the numerator, 0 in the denominator, and you can't divide by 0. So that triangle there shows you all four types of slope. We also talked in the last video that slope is rise over run, and that your slope formula is y2 minus y1 over x2 minus x1, and that's really important. The first thing we're going to look at in this video is how to graph a line, and to do that there are 3 steps, and the first step is to plot the point that they give you. And remember, on a coordinate plane, points are written x, y. So we go horizontal first and then vertical. Second thing to do is to count the slope, and it's important that you do that from the point. Okay? Don't go to a different point. Don't go back to the origin, which is where the x and the y axis meets. Go from the point that you just plotted. So step 1 is to plot that point. Step 2 is to count the slope from that point. And then step 3 is to connect those to make a line. And they should all be on one line together. Now, as a quick note, I want 3 points for your line. So you're going to have to do steps 1 and 2 twice in order to get those 3 points. You're going to plot a point, count a slope, put a point there, which is going back to step 1, and then count your slope again. So you have to repeat that twice. Our example says 2, 3, and we want a slope of negative 1/2. So remember, our step 1 is to plot this point, 2, 3. So we go over to the right 2 and up 3. We've plotted our point. Step 2 is to count that slope. So we've got to go down 1 and then to the right 2, and we go down 1 because the numerator's negative, the denominator's positive, so we got to go to the right. And we put a new point there. So now we have 2 points. I said I want 3 points on your line, so you got to repeat that. We have our new point. We're going to just count our slope again. We're going to go down 1 to the right 2 and plot a new point. Right, there are our 3 points. Now step 3 was to connect them to make a line. And that's it. That's all we have to do to graph a line. Just make sure that when you count the slope, you're counting from the point you plotted. Don't go back to the origin. That's usually the common mistake I see. People will go to the origin here and count from there. You count from the point that you plotted. Now the next big idea is parallel lines and slope. And what I want you to remember is that parallel lines will have the same slope. Okay, parallel lines will have the same slope. So if I know one line has a slope of, let's say that line we used in our example up there, a negative 1/2, something parallel to it is going to have a slope of negative 1/2. They're going to be the same. Okay, that's the important concept on parallel lines. Same slope. And the reason they have the same slope is so that they will never intersect. If you've got 2 different lines, they should be going up and over at the same each time, the same amount every time, so that they will never intersect. The other big idea is for perpendicular, and there's a rule that you need to remember. I'm going to give you 2 different ideas for slope for perpendicular lines. The first one is to flip and change the sign. Okay, that's the first big idea. So if you had something with a line with a slope of negative 1/2, you would flip it. So it would become 2 over negative 1, And then you need to change its sign. Well, that's negative, so it's going to become 2 over positive 1. And there's your new slope, 2 over 1 or 2. That's how you get a perpendicular slope. Now the other idea, and you may see this, is that they multiply to negative 1. Perpendicular slopes will multiply to negative 1. And that's the actual theorem part of perpendicular and its slope. But we're going to remember this shortcut. We're just going to remember to flip and change the sign. Now we've got 2 examples down here. The second one's going to be your pause and practice problem. Okay, so we're going to do the first one together. It says determine if AB and CD are parallel, perpendicular, or neither. So we have to take these points, A to B and C to D, and we've got to find the slope of each of them, because AB is a line, CD is a line. And then we're going to compare them, and we're going to see if they are parallel, perpendicular, or neither. Now remember, parallel means they have the same slope. Perpendicular, one of them should be a number and the other one you should flip and change the sign to get it, or they could multiply to negative 1. And it would be neither if they're not parallel or perpendicular. They don't meet either of those rules. So let's start with AB. I'm going to put my x1, y1, x2, y2 in there to help me get those numbers in the right order. So it would be 5 minus 4, that's my y2 minus y1, over my x2 is negative 4 minus a negative 2. You same add reverse on the bottom. On the top, it is 5 minus 4, which is 1, over negative 4 plus 2 now because we same add reverse. So we get negative 1/2. Now let's find CD. Let's put our x1, y1, x2, y2. So CD is going to equal 3 minus 2 over negative 2 minus negative 1. Same add reverse on the bottom there. I'm going to go ahead and change that. 3 minus 2 is 1 over negative 2 plus 1. That's negative 1. That reduces to negative 1. So there's the slope of our second line. Let's compare them, okay, because we got to figure out if they are parallel, perpendicular, or neither. Looking at those two slopes, they're not the same. So you can automatically rule out parallel. Okay, they are not parallel because the slopes are not the same. Perpendicular. That means you would flip and change the sign of one and you should get the other. Well, if you flip a negative 1/2 and change its sign, you don't get negative 1, you get 2. So they're not perpendicular either, which would mean the answer to the problem is neither. Alright? Since they're not the same slope, they're not parallel, you don't flip negative 1/2 and change its sign and get negative 1. So they're not perpendicular. I've got you a pause and practice problem here. Your points are 1, 1 for A, B is 9, 8, C is negative 6, 1, and D is 2, 8. And I want you to do the same thing the directions for the one above it said. Determine if A, B, and C, D are parallel, perpendicular, or neither. Go ahead and work it out, and then come back and check your answer. Alright, let's go ahead and get started. We've got A, B, and C, D. Let's find the slope of AB first. Let's put in our x1, y1, x2, y2. y2 is 8 minus y1 is 1 over x2 is 9 minus x1 is 1. Now simplify that. 8 minus 1 is 7 over 9 minus 1 is 8. Alright, so let's figure out CD now. CD equals, let's plug in our x1, y1, x2, y2. y2 is 8 minus y1 is 1 over x2 is 2. x1 is a negative 6, so minus a negative 6, and we same add reverse there. 8 minus 1 is 7 over 2 plus 6 now is 8. Notice we got the same slope for each one of these, which means they are parallel. So if you got that, you did it correctly. If not, go back and find your mistake and change it. And those are your notes on Section 3.3, Part 2, graphing lines and parallel and perpendicular.